We're in section 8.3, testing a claim about a mean. It is very rare that we test a claim about an unknown value of a population mean, mu, but we somehow know the value of the population standard deviation. When the standard deviation of the population is unknown, the test statistic has a distribution called the student t-distribution. The test statistic for the testing a claim about a mean is, and it's given to you guys below, we saw this last chapter. I'm going to go ahead and give the box down here a star. This is testing a hypothesis regarding a population mean p-value approach with an 83 or 84 calculator. Use the following steps provided that we need to check two things. The sample is a simple random sample and that the population is normally distributed, or the sample size n is larger than or equal to 30. Step 1 is determining your null and alternative hypotheses. The null is always mu is equal to mu naught. And your alternative depends on if it's a two-tailed, left-tailed, or right-tailed test. Step 2 is alpha. If alpha is not given to you, you can select the value. Again, most students will select 0.05, but most of the problems will give you alpha. Step 3, find the p-value and test statistic. So test, we're going to go from stat button to test. Go down to number 2, it's t-test. If raw data is given, listed numbers, we're going to go to data, put the list into L1 and the frequency needs to be set at 1. If summary statistics are given, highlight stats, and mu naught is the value of the mean stated in the null hypothesis. Select the direction of the alternative hypothesis, not equal to, less than, or greater than. Highlight calculate, and then you're given two values that are important to us. One is the test statistic. This time it is a t-test statistic since we're using the t-distribution. And p is our p-value. And then the testing is done exactly the same as we saw last chapter. It's if the p-value is less than alpha, we reject our null hypothesis and then state the conclusion. So right down below on the next page is an example. It says in 1990, the mean height of women 20 years of age or older is 63.7 inches based on data obtained from the CDCI and the Prevention's Advanced Data Report number 347. Suppose that a random sample of 45 women who are 20 years of age or older today results in a mean height of 63.9 inches and a standard deviation of 0.5 inches. So there's a few different parts on here that we are going to be looking at. First one is going to be, is all the criteria met in order to perform the test? There were two things that you need to check. First, it needs to be a simple random sample. And it says it's a random sample. So I'm going to go ahead and put SRS for simple random sample. The other thing that we need to check is that our sample needs to be greater than or equal to 30. And for us, our sample is 45, which is greater than or equal to 30. So check. So these are both these criteria have been met. So we can perform the test. Part B says state the appropriate null and alternative hypotheses, assuming to assess whether women are taller today. So we have H0 and H1 for our hypotheses. It is talking about the mean height. If you notice the word means thrown all over the place, so I'm going to go ahead and put mu's on both of these. Your null always has an equal sign. And we're trying to figure out if women are taller today. So that's going to be greater than. The value that goes in here is what we have for our population, not from our sample. And if you notice, there's a lot of different values in here. Our population, the height that we had before was 63.7. And that number goes in both hypotheses. And again, greater than because taller would mean larger. The next thing on here says use the p-value approach to test the claim that women are taller today. So again, we're testing that claim that they are taller, which we wrote up above with our null and alternative. So a few things that you need. First one is we need to know X bar. And if you notice with our sample, it was 63.9 inches. Our standard deviation for the sample is 0.5 inches. And our sample size that we wrote up above is 45. So we are going to use a t-test. Go ahead and enter in all those values. Again, mu naught is 63.7. When you do this, you're going to get a p-value equal to 0.0051, which is, we don't have an alpha. So when we don't have an alpha, you get to select the alpha. So we'll just say, let's assume alpha is equal to 0.05. This usually doesn't happen on MyOpenMath just because it is a program that they use. But if you were to be conducting your own investigation on something and trying to figure out a test, you would have to come up with this alpha value on your own. If you notice, this p-value is really small, so it's less than pretty much any alpha that you would select. And since this is less than alpha, that means that we are going to reject H naught. So we need to state our conclusion. So there is sufficient evidence and we'll say at the alpha equals 0.05. Level of significance to conclude that women are taller than in 1990. There's an example right below this. It says to test H naught, which is going to be mu equals 4.5 versus our alternative, which is greater than 4.5. A simple random sample of size n is 13 is obtained from a population that is known to be normally distributed. It says it is known to be normally distributed. We need to know that because our sample size is small. Our sample size is only 13, so it needs to be coming from a population that is normal. Otherwise, we cannot conduct this test. So first of all, it gives us if f bar or x bar equals 4.9 and s equals 1.3, compute the test statistic. So in order to compute our test statistic, we are going to go to t-test and enter in all of the values that we have. And again, they already gave us our null and our alternative. They're listed up above. So mu naught is 4.5. We know x bar is 4.9, s is 1.3, and our sample size n is 13. Once you have all those values in, you go to t-test, go down to calculate, hit enter, and let's go ahead and round this 3 decimal places. So t is going to be your test statistic. It's 1.109. Part B says draw a t-distribution with the area that represents the p-value shaded. So drawing our normal distribution, that is a little bit wider because that's what a t-distribution is. And it says the area in the p-value is shaded. So again, with the t-distribution, that's zeros in the middle. Our test statistic is 1.109, which is somewhere on the right of the mean. And then this area is shaded to the right, over here in our right-tailed test, is equal to our p-value. And our p-value, which is also given to us on the calculator, is 0.1445. And again, round your p-values, always 4 decimal places unless otherwise stated because they are probabilities. So you can see where the test statistic is and how that relates to the p-value. Part C says approximate and interpret the p-value. Well, we have the p-value up above. And so to interpret this, we would expect about, and I'm going to write it as a percent, 14.45% to have a mean of 4.5 or higher. Which again is what we have that we're testing. It says if the researcher decides to test this hypothesis at the alpha equals 0.1 level of significance, will the researcher reject the null hypothesis and why? So the p-value from up above is 0.1445, which is larger than alpha, which is equal to 0.1, which means that we are going to reject, do not reject. So do not reject.